morning. Today we're going to be doing trig form of a complex number. By the way, you guys, every day I am looking on Schoology and I can tell when you've logged on and when you've clicked on each one of the links. So every day that I put work up there, make sure that you click on each link, the notes, the video, click on the homework to correct it. Remember, because this is a college course, we have to move forward, and I am starting to grade your work now. Right now it's just being graded for effort, but every day when I log on to Schoology and I post stuff on Schoology, you have to be doing everything every day. Don't forget that the weekly review sheet is due on Friday. I put it up as a separate PDF file, so it might be easier for you to print it. So today we're going to do trig form of a complex number. My thought of the day, there is nothing better than encouragement of a good friend. So I'm trying to be your friend and encouraging you. Keep going with pre-calc. All right, so when you set up the trig form of a complex number, the x-axis is still labeled x, and the y-axis is now labeled yi. So I'm going to call the distance on this triangle A. That's the x distance. I'm going to call the y distance B. So that's the length of that side. Remember that this is a right angle. This is our theta, our reference angle. And the hypotenuse, which again is always positive, is going to be lowercase r. So our hypotenuse, we're going to use the Pythagorean theorem to find it. C squared is equal to a squared plus b squared. R squared, our hypotenuse, will be the two sides, a squared plus b squared. So if you take the square root of both of these, r, the length of the hypotenuse, is equal to the square root of a squared plus b squared. And the reason we're only using the positive square root is the hypotenuse is always positive on these triangles. So the hypotenuse is going to be labeled r. So the way we're going to derive the trig form of a complex number is we're going to start by finding the cosine of theta. Cosine of theta is equal to adjacent over hypotenuse. The cosine of theta, the adjacent side is a, lowercase a. The hypotenuse is r. I'm going to cross multiply and solve this for a. You'll see why in just a minute. It has to do with a plus bi form. If I cross multiply and solve this for a is equal to r times the cosine of theta. Now I'm going to do the same thing for the sine. Sine of theta is equal to opposite over hypotenuse. The sine of theta, the opposite side is lowercase b, the hypotenuse is r. I'm going to cross multiply and solve this for b because of a plus bi form. So when I cross multiply, r times the sine of theta is equal to b. Now, the trig form of a complex number. Remember that a complex number is a plus bi. Our a is r times the cosine of theta, plus our b is r times the sine of theta. And don't forget that you have to have that I in there, a plus bi. And the trig form of a complex number, for some reason, is denoted by lowercase z. I don't really know why. And what you can do on this side of it is GCF factor out the r. So if I pull out the r, I'm left with the cosine of theta plus I times the sine of theta, and this is the trig form of a complex number. We're going to have to use that to do a bunch of things. We're going to be multiplying, we're going to be raising them to powers, we're going to be dividing. As far as the angle theta goes, we're always going to use our tangent function to find theta. Tangent of theta is equal to opposite over adjacent. So the tangent of theta is going to be the opposite is side B, the adjacent is side A. And we're going to use that because that uses the two givens. All right, let's look at example number 1. Example number 1, we have to find the trig form of each complex number. And for example number 1, the complex number is 4 radical 3 minus 4i. Now, here's our a plus bi for our complex number. The a value is going to be our x value, and our bi value is going to be our y value. So if I graph this complex number, my x value is positive, my y value is negative. That's going to put this triangle into quadrant 3. Here's theta. My x value is 4 radical 3. My y value is negative 4. You don't have to put the I with it because the y-axis is yi right now. To find the hypotenuse r, it's going to be the square root of these two sides squared. So 4 radical 3 squared plus a negative 4 squared. Remember, that's using the Pythagorean theorem. So the hypotenuse r, when I square 4 radical 3, 4 squared is 16, radical 3 squared is 3, a negative 4 squared is a positive 16. R is equal to the square root of 48 plus 16. 48 plus 16 is 64. The hypotenuse, or our r, is equal to 8. So this side is 8. That's our r. Okay, now the trig form of we have to find our angle theta. We need to use the tangent function to do that. Tangent of theta is equal to opposite over adjacent. Tangent of theta, our opposite side is a negative 4. Our adjacent side is 4 radical 3. So this is negative 1 over radical 3, or negative radical 3 over 3. We have to get our reference angle in quadrant 1. So over here, I have my unit circle. Please practice doing your unit circle. Please run through it daily. You're really going to need to know that for your final exam. And somehow there is going to be a final exam in this course. So please, please, please keep up with the instruction. My theta prime, where in quadrant 1 is tangent positive radical 3, inverse tangent of positive radical 3 over 3, my theta prime is pi over 6. And when I take pi over 6 and I reflect it down here into quadrant 4, for this trig form of the complex number, it will be 11 pi over 6 in quadrant 4. All right, so now I've got all the building blocks that I need. So the trig form of my complex number, z is equal to r times the cosine of theta plus I times the sine of theta. The trig form of this complex number, r was our hypotenuse, it's 8 times the cosine of theta is 11 pi over 6 plus I times the sine of 11 pi over 6. This whole bottom line is the answer. Again, my notes are posted for you on Schoology, so please follow the notes. The next example is negative 4 minus 4i. Negative 4 minus 4i. So here's our a plus bi. It's also x plus yi. So the negative 4 is our x value, the negative 4i is our y value. That's going to put this triangle into quadrant 3, where x and y is both negative. So in quadrant 3, right angle, theta, my x value is negative 4, my yi value is negative 4. So this is an isosceles right triangle, or a 45, 45, 90 right triangle. You could absolutely run through the Pythagorean theorem to find the hypotenuse, but if you remember your 45, 45, 90 right triangle rules, it's x, x, x radical 2, so the hypotenuse is going to be 4 times the square root of 2. That's what our r value is. Or again, you can run through the Pythagorean theorem. Now we have to find our angle theta. We're going to use the tangent function. Tangent of theta is equal to opposite over adjacent. The opposite side is negative 4, the adjacent side is negative 4. So the tangent of theta is positive 1. I mean, my reference angle in quadrant 1, theta prime, is equal to inverse tangent of positive 1. In quadrant 1, where tangent is positive 1, is pi over 4. And now I have to take that pi over 4 and put it into quadrant 3 where the triangle is. So in quadrant 3, theta will be equal to, use your unit circle, it'll be 5 pi over 4. So we have the building blocks to write the trig form of our complex number. The trig form of the complex number, z, is equal to r times the cosine of theta plus I times the sine of theta. Z is equal to, the hypotenuse is 4 radical 2, that's what r is, times the cosine of. Theta in quadrant 3 is 5 pi over 4 plus I times the sine of 5 pi over 4. Example number 3. Is 2i. Okay, every imaginary number, like 2i, can be written as a complex number in a plus bi form. So this is 0 plus 2i, x plus y, I, or a plus bi. So our x value is 0 and our y value is positive 2. So that would put this on the y-axis. So it's not in one of the quadrants. I know that r has been the hypotenuse of the triangle, but r is also the distance from the origin to the vertex of the triangle. So for this situation, our r is this y distance, our r is 2. And our theta is the rotation of 90 degrees, so our theta is pi over 2, or 90 degrees. The trig form of this complex number z is equal to r times the cosine of theta plus I times the sine of theta. The trig form of this complex number, r is 2 times the cosine of pi over 2 plus I times the sine of pi over 2. Then the last example that I'm going to do. I'm going to do example number 4, and then I think you guys will understand example number 5 from looking at my notes. This one, you're given z is equal to 4 times the cosine of 5 pi over 6 plus I times the sine of 5
example number 4, we're given the trig form of the complex number, and we have to write it in complex form, a plus bi. So we're going to kind of work backwards. This is really easier than the other examples that I've done. So my a plus bi form is going to be equal to 4 times. Now, I have to refer to my unit circle again. I'm going to find 5 pi over 6 on my unit circle. And again, it's real important that you guys have a unit circle in front of you and that you're practicing doing it every day. The cosine of 5 pi over 6 is negative radical 3 over 2. Remember, it's the x value of that rotation. And the sine of 5 pi over 6 is 1/2. And don't forget that there's an I in there. And then to write this in a plus bi form, all you have to do is distribute the 4. A plus bi, 4 times negative radical 3 over 2 is negative 2 radical 3. Distribute the 4 plus 2i. Okay, so example number 5, I think you'll understand. Again, my notes are on Schoology. Please make sure that you copy the notes, that you click on the video, that you do the homework, and that you correct the homework tomorrow. And remember, I'm going to be checking every day that you're doing all 3 things. Again, I hope you're all well. I hope you're doing okay. I miss you. I can't wait to be back together in school with you. Message me on Schoology or send me an email if you have any questions. Have a happy day. Bye, guys.